So today I'm going to be talking about the mobile site native app accessibility testing guidelines, specifically basically what they are so that you can actually apply them when creating accessible games. The first thing I'd like to do is acknowledge the Yugara people as the traditional owners of the land. They still have a strong attachment to the area. I am here from Australia, from Queensland. It's 8 p.m. and still 28 degrees. So that's, I don't know, maybe 95 degrees Fahrenheit. So yeah, it's pretty warm here. The first thing I'd like to do is say, if you'd like to access the presentation, because that's kind of the first question I always get, you can go to the Accessibility Oz conferences page, and I'll put it up after the presentation. Go to About, and then the conferences page. And as you can see, you've got JetBrains here. It will move down to parts conferences, and I will include the PowerPoint presentation so you can have a look at that. I'd like to introduce you to our team. This is a photo that was taken a while ago at CSUN in California. CSUN's one of the biggest accessibility conferences in the world. And when I started Accessibility Oz, I wanted to support people with disabilities by providing them with employment opportunities, as well as creating accessible websites. And so over the almost 15 years that we've been operating, we haven't had any less than 60% of our staff have some kind of significant disability that affects their daily life. And when you look at us, we all look normal. And that's something to be aware of, is that just because you know everyone that's using your system or your website, your game, and none of them look disabled, that doesn't mean that they aren't. About 20% of the population has some kind of significant disability that affects their daily life. That doesn't mean the need to use glasses or anything like that. Significant disability. And it's often you can't tell just by looking at someone, and it's really quite rude to ask. So over the, as I said, almost 15 years that we've been running, we've had people with dyslexia, moderate vision impairment, severe vision impairment, epilepsy, migraines, physical impairment, fibromyalgia, multiple sclerosis, Crohn's disease, post-traumatic stress disorder, autism, and long COVID. And one thing to remember is it's not just about vision impairments. A lot of people, especially if they're new to accessibility, think that accessibility is all about making things accessible to a screen reader. That's absolutely not the case. Of course, it's very, very important. But the largest group of people with disabilities who use the web are actually people with cognitive disabilities. And they often have diametrically opposed requirements to people with vision impairments. So people with vision impairments prefer text instead of images. People with cognitive disabilities prefer images instead of text. So if you're like, hey, I'm just going to create this text-only site for all the people with disabilities, you're actually locking out a large group of disabilities, people with disabilities by doing so. A little bit about me. Sorry, just one moment. Go on. A little bit about me. I started in 1998. I like to joke that I started when I was 5 years old, but that was not the case. I worked on the very first accessible website in Australia. I created Australia's first automated accessibility testing tool. I was an invited expert to the W3C WCAG working group, so I contributed to writing WCAG 2, which are the guidelines that you need to follow to make things accessible. I worked on the Melbourne 2006 Commonwealth Games and every Commonwealth Games since then. And I then spent 5 years managing usability and accessibility services at Monash University, which is one of our Ivy League colleges here in Australia. So I know what it's like to be on the other side. In 2011, I founded Accessibility Oz. We released a couple of products. I spoke at the United Nations on the importance of accessibility in disasters. And I was inducted into Australia's Hall of Fame as Accessibility Person of the Year in 2019. And I also spent the last few years as chair of the Mobile Accessibility Testing Guidelines. So that's what we're here to talk about. That's all just to prove that I do know what I'm talking about. So let's get on to these guidelines. guidelines. So a little bit of background. Why did we develop this methodology? So if you know anything about accessibility, you should know that there's this thing called the Web Content Accessibility Guidelines, and that's what you need to follow to make your content accessible. However, really, it doesn't go far enough when it comes to developing native apps or websites that you view on mobile. And so at a conference called the ICT Accessibility Testing Symposium in 2017, we all get together as a community. So we were all accessibility testing specialists. And at the end of that conference, they always have a town hall where they say, hey, what is it that you would like to see change in the community? And in 2017, the overwhelming discussion was around how there weren't guidelines for mobile accessibility. Well, actually there were guidelines, but everyone had their different set of guidelines. So Accessibility Oz had our own, every different accessibility company had made up their own guidelines. So we decided to form a committee at that point to come up with guidelines. And initially we just amalgamated everyone's guidelines and said, this is what, this is what the mobile guidelines should be. And we did that because we knew that WCAG 2.1, it was going to be released in 2018. And it was released a couple of weeks after we released our mobile guidelines. And we were like, once WCAG 2.1's released, which is kind of iterative version of WCAG, it's going to address all the mobile stuff. We don't need to worry about developing these guidelines any further. So what about WCAG 2.1 and 2.2, which has also been released? So as I mentioned, WCAG 2 are applicable to mobile. However, not all aspects of mobile accessibility are specifically covered by WCAG. So, for example, WCAG 2 requires that sites be fully accessible to the keyboard user. However, it doesn't require that everything be fully accessible to a mouse user or to a touchscreen user. WCAG 2.1 does build on this and includes more criteria-related touchscreens, pointer gestures, things, etc. However, it really doesn't cover all the user needs. And so that became patently obvious when 2.1 was released, because we had another big gathering at a conference, and we all found that there was one success criterion that we all agreed on, and that was that touch targets had to be a specific size. So they had to be, the links had to be a certain height and a certain width. We all agreed on that. And yet WCAG 2.1, it did have a touch target size requirement, but it was relegated to level AAA. So there are 3 levels to WCAG: level A, AA, and AAA. And everyone is meant to follow level A and AA, and AAA is seen as the nice to have. I like to say level AAA is where success criterion go to die. And guess where the touch target size requirement was? It was in AAA. So we reformed the committee and we went, you know what? We need to do this properly. And we spent 2 years writing very detailed mobile guidelines, including how to test with examples, etc., etc. And so that's how this came about. Please note that this methodology does not include anything that's already in WCAG 2, but it does include things that are in WCAG 2.1. And at the moment, it does not include WCAG 2.2 because it was published before 2.2 was released. So where can you find these guidelines? If you go to the Accessibility Oz website, you'll see that under resources, there is the link mobile testing, and that is where these guidelines are. So you have this introduction, why we did it, and some webinars. So something like this you can access as well. There are some blog posts about part of the functionality. We talk about WCAG 2.1 and 2.2, mobile sites versus native apps, and hybrid native apps. And then we have the methodologies. So there are 2 sets of methodologies. One is the mobile site methodology and the other is the native app methodology. They are very similar, but we did find it was easier to pull them apart. And basically you have this methodology, which is the equivalent of your success criterion in WCAG. So these are the rules that you need to follow, but just the rule itself, not how you would go about doing it. And then And so you have that for mobile site and native app. And then you have an about, this document. So about talks about devices, assistive technologies, site types, variations of the page, capturing errors, etc., specifically to mobile sites or specifically to native apps. And then you have the 3 documents that have the methodology in much more detail. So you have a document on critical test cases, a document on test cases, and then assistive technology test cases, once again for mobile sites and for native apps. I know Word documents, not great. We are trying to convert them into an online resource, but there's so much information there. So that's how they are available at the moment. And I also want to let you know, even though it's on the Accessibility Oz website, that doesn't mean it's actually an Accessibility Oz product. The only reason it's on the website is because I was the chair, and after it was published, it was on the testing conference website, which it is now, links back to us. And I just kept sending them updated versions saying, I found this typo, or, this heading's at the wrong level. And they went, oh my God, Gian, just put it on your website and we'll direct it to you. So it was developed by a whole bunch of different accessibility companies, people with disabilities, software vendors and things like that. It is a bipartisan document. And the thing to remember also when it comes to accessibility is that's kind of what we do as an industry. WCAG, the very first WCAG, was released in 1998. It was actually written in 1995 by just a random group of accessibility specialists who got together one day and said, hey, we need some guidelines for this new thing, the web, to make sure that people with disabilities can use it. So they created the guidelines, updated it a few times, and then the W3C took it over. So, and that is by far not the first time, and not the last time that has happened. So this is very common in our industry. We do find that the W3C, which is really kind of responsible for the policy documents, doesn't move very fast. As an example, WCAG 1 was released in 1998, WCAG 2 was released in 2008, WCAG 2.1 was released in 2018, and WCAG 2.2 was released in 2023. So there's a long time. There's a lot of difference between 2008 and 2018. If you think about it, the iPhone was only released in 2007. The web content accessibility guidelines have been completely written by then. So that's why it doesn't include all these mobile kind of things, because there were no mobiles. We had monochrome displays on flip phones. And I did do some testing of mobile sites like that. It was very unfriendly. We had no concept of no native apps or anything like that. So the reason why this is here is because we just don't feel that the W3C moves fast enough. So why is mobile so different to, say, a desktop? So firstly, there are native screen readers and other native assistive technologies that you just don't get in the PC world. In a Mac, of course, you have an inbuilt assistive technology called VoiceOver. But if you're using a PC, you could use, the Windows narrator, but it's absolutely terrible. Anyone who actually needs a screen reader would not be using Windows narrator. So you have to download NVDA or JAWS or something along those lines. And so when it comes to mobile, there's a huge variety of assistive technologies and features that people use even if they don't consider themselves having a disability. For example, I use dark mode, which reverses the colors. So I see white text on a black background. I do it mainly to conserve battery, but that's something that I don't use on my desktop. My stepmother, for example, she reads all her books on an iPhone now because she significantly increases the text size. She would never ever consider going into a library and asking for a large print book, but that is exactly what she's doing. So these kind of assistive technologies are much more commonly used on mobile devices. So you have to be much more careful when you're developing these systems to make sure they operate correctly with them. You have a level of volume control that you don't usually have on desktop. If you think about how many times you change the volume on your phone versus the volume on your desktop, you have things like a vibrational keyboard. There's visual, auditory, and vibrational notifications. There's screen rotation. I personally have 3 screens. I have a landscape, and a portrait. And I can tell you there are a lot of websites that do not work on a portrait screen. But of course, that's what we're expecting on a phone. But there are some people with disabilities who have their phones affixed to, say, their wheelchair or something like that. And so they can't change their orientation. So allowing things to operate in multiple orientations is really important. Mono audio, voice control, increased text and display size, reduction of motion, zoom, and then things like reader and simplified view. Another thing that makes mobile really interesting is the page variations. So as part of WCAG 2, you should be able to, on your desktop, zoom to 200% on any browser and still be able to use the site properly. So of course, that's not included in this methodology. But people who do that and increase the zoom to 200 or 300% often end up triggering the mobile version of the site on their desktop. So what does that mean? It means there are some people with disabilities who only ever see a mobile version of your page. So that means that everything that you have on your desktop website, you need to have on your mobile website as well. This is a really good example. This has been fixed. So this is YouTube, and this is a screenshot of YouTube on desktop at 100% screen size. And you can see in the top right-hand corner, there's the upload and the notifications button. Now, if you increase the text size to 200%, it disappears. So all of a sudden, you can't upload or access your notifications if you're looking at the page at 200% on desktop. Now, why would that be the case? Because that screen size, the developers assume that you would only be looking at it on your mobile phone. And they don't want you to upload videos through the YouTube mobile site. They want you to upload videos. Upload videos on the YouTube native app. So they've taken that functionality away. But that means people who increase text size on desktop, they're not going to be able to do it. So that's one thing to remember when you're talking about different screen variations and things like that, that you need to make sure you have the same amount of content in every single variation. It doesn't have to look the same. It could be hidden under a collapsible menu or something like that, but it all needs to be there. So another thing to remember is under WCAG 2, there's something called accessibility supported. Basically, you need to use implementation techniques that support assistive technologies. So if you use, say, PDF, then you need to tag the PDF using the PDF accessibility features. What does this mean for mobile? So what this ends up meaning is that when you are using native apps, you need to really test to ensure that the assistive technologies work with those native apps. And this is much more important with native apps than it is for a mobile site, because you can't access the code of a native app if you're testing. Obviously, if you're building, it's different kettle of fish. But if you're testing, you can't access the code of a native app. So sometimes the only way to determine if something has an accessible text alternative is to actually use an assistive technology. So the assistive technologies that are included in this set of guidelines are for Android: talkback, keyboard and switch, magnification, remove animations, color inversion, grayscale, color correction, increase display size, increase font size, increase text size with Chrome, and simplified view for mobile sites only. For iPhone, it's voiceover, keyboard and switch, zoom, reduce motion, invert colors, grayscale, large text for native apps only, reader view for mobile site only, and reader view and increased text size for mobile site only. Now, exactly the same assistive technologies also need to be tested on an iPad if you are testing for iPads, because it uses a completely different operating system. So if it works on your iPhone, doesn't necessarily mean that it works on your iPad. So testing methods. There are a variety of testing methods when it comes to mobile testing. For mobile sites, there are 4 main testing methods. You test on a device, you test on a device with an assistive technology, you test on a responsive window, or you test on desktop. When it comes to native apps, there's only 2 testing methods: testing on devices and testing on devices with assistive technologies. And so I know you're all going to say, no, but we've got simulators, so we can test on a bunch of things. We don't need to test on actual devices. This is why you need to test on actual devices. So I used to fly to the States fairly regularly, and we'd get to LAX and we'd sit on the tarmac for like half an hour or an hour. But the one good thing is that back before planes had Wi-Fi, you could access the LAX Wi-Fi on the plane. But if you did so, you get this page, and it has small text here that says, this page will redirect, so content doesn't really make sense to have here. And all of a sudden, I don't really feel safe for giving you my contact details. Now, how does this happen? This happens because this was tested by and developed by someone who is sitting in front of a desktop. They've never tested it on their phone in that actual location, in the way that people would actually use it. So that's why you have to test with real devices. And also, when it comes to assistive technologies, the simulators are absolutely rubbish at showing you what the assistive technology will say or do. Even if they are, browser farms and they have mobiles that you are supposed to see the actual screen of, still absolutely rubbish. So you cannot use them. So the actual methodology, the methodologies have the same 5 steps with the exception of step 2. So the mobile site methodology is identify devices, identify site types and variations, test critical issues, test mobile specific issues, and test mobile assistive technology and feature support. And then for the native app, it's exactly the same except for step 2, which is define application functionality. So for step 1, identify devices. Firstly, you should determine what devices your system should work on. So in the United States, Australia, other Western countries, iOS devices are most popular. In Asia and other Eastern countries, Android devices are most popular. So if you have a site, the best way is to look at Google Analytics to determine who's using your system and then build from there. In terms of the Android system, there are actually tens of thousands of Android operating system and browser combinations available. It's not possible to test on all these systems. And also another thing to remember is that the internet browser that comes pre-packaged with most Samsung phones is very dependent on that operating system itself, and a better representation is to test with Chrome. So whatever Android of what a lot more people will see. And just remember that even if the site is a desktop site, people will still use that desktop site on mobile, and I'll talk about that in a moment. And then when it comes to devices with assistive technologies, it's important to remember that there are assistive technologies that are named the same, say that work on a Mac and work on iOS, but they are actually different technologies. So you can't say, oh, I tested this on a Mac with VoiceOver, so I don't need to test VoiceOver on my iPhone or my iPad. You do have to, because they're actually completely different technologies. They're just labeled the same. If you want to talk about screen readers read aloud the content on a page for people who are blind. There is a WebAIM screen reader survey, which talks about which are the most popular screen readers. If you're talking about mobile, the only 2 that you really need to worry about are VoiceOver for iOS and TalkBack for Android. Be aware that Samsung does, because Samsung likes to be different. They have an additional screen reader called Voice Assistant, but TalkBack is still available. And Amazon Fire also uses a different screen reader called Voice View. So if you look at your your statistics and you find that 90% of the people using your system are using Samsung devices, then maybe consider testing on with Voice Assistant. If you have a system that's going to work exclusively on Amazon Fire, then you need to test with VoiceView. In reality, though, TalkBack for Android and VoiceOver for iOS is sufficient. The recommended devices and browser combinations are iPhone with Safari, iPad with Safari, and an Android phone with Chrome. You should also consider an Android tablet with Chrome and alternative devices such as a Kindle if your system can operate on those. The guidelines recommend that you test on the latest version of iOS and iPad OS and the latest 2 versions of Android. However, in the use of this testing methodology, I found that it's actually sufficient just to test on the latest version of Android. So that's something that you can, reduce your testing. And just think also, when a site is directly aimed at people with a particular kind of disability, you can consider including assistive technologies used by potential users. So, for example, if you have a site or a game that's aimed at people with acquired brain injury, then you should be testing with an assistive technology like Dragon Naturally Speaking, because that's what they use. I did notice in the chat that someone said, and does anyone knows if this is pre-recorded? It's absolutely not pre-recorded, but there is a recorded version of this on the mobile page if you would like to access it later. And just another note that you need to meet WCAG 2 and this mobile testing methodology. So step 2, when it comes to determining what it is that you should be doing, you need to really identify the site type and variations of the page. So is your site going to be a desktop, MDOT, responsive site? If the site is responsive, are there variations of a page? So basically, desktop sites are ones that have only one display, whether viewed on desktop or mobile or tablet. MDOT, they have a particular display for mobile and tablet sites, and it's actually a completely separate site. So you have a www site that is on your desktop, and then an m.dot site, which is completely different code that you see on your mobile. And then responsive websites that change depending on the screen size or other feature determined by the developer. And that's, of course, the most common. So this is an example of a desktop site, and basically what you can do is if you drag the browser window smaller, you can see nothing really changes, it just gets smaller. And so it's not very common to have desktop sites anymore, but they do occur. And if you are wanting to identify an m.dot site, you need to really do 3 things, which is ask the client if they have an m.dot site, then change the URL to start with M instead of www, and then compare the site on desktop to the site on a mobile device. And so this is something that seems like overkill, but I did do some training for Stanford University, and I asked them, do you have an m.dot site? They said, no, we don't have an m.dot site. Guess who had an m.dot site? So, of course, this is not really applicable if you are building games, but it's something to be aware of, and it's something, a good reason to explain to people why everything should be responsive. So this is the Sephora website, and this is what it looks like, the www version on desktop, and this is the m.dot version on desktop. You can see it's got a hamburger menu, it's much cleaner, and if you look at them both on mobile, you can see that they are very different. So that's an m.dot site. So most likely sites are going to be responsive. If a site's responsive, it's definitely not desktop, but there could still be an m.dot site. Easy way to identify a responsive site is basically change the size of the browser window. If you have a site like this, you make the window smaller and it actually changes quite significantly. That's how you identify it. Now, if you ever go, oh my gosh, I have no idea what she's talking about, all this information is in the documentation. So the next step when it comes to determining what should be accessible for native apps is define application functionality. So through your understanding of the purpose of the native app, define which functionality is critical to its purpose and use, and that must be tested for efficacy, operability, and workflow from a user experience perspective. So for example, if you think about the Wells Fargo website versus the Wells Fargo app, they do very different things. The Wells Fargo website might have their share price, how you can apply for a job, store locations, when they're open, etc. And the Wells Fargo banking app will be specifically about banking. So you find that native apps have much more streamlined information and content, and that's what you need to be aware of when looking at accessibility. So ask the question, how would the experience be impacted if the functionality failed, the content could not be reached, and or the experience caused a barrier to the user, and then prioritize. So all functionality should be accessible. However, it's important to define and include the critical functionality for each individual app to be prioritized in the testing. And then there are common elements that need to be tested to make sure that they are fully accessible: navigation, landing screens, emergency sections, login flows, settings, account and profile, contact us, real-time updates, privacy policy, terms and conditions, interactional functionality, help section, widgets, calendars, geolocational maps, and high traffic areas. So now that you know a little bit more, you might be a little bit more interested in looking at the guidelines. So I'll just show you again. You just go to the resources and then mobile testing, and that's how you can find it. So the next step is testing critical errors. And so this is where there are traps. New features mean new traps. A trap is where a user is trapped within a component and cannot escape without closing the browser or the app. There are many more traps in mobile sites and native apps than on desktop. The most common one known on desktop is the keyboard trap. You tab into a component, but you can't tab out of it. So the only way to escape is to close the browser and start again. We identified that there are 5 different traps that can occur on mobile sites and native apps: the exit trap, the swipe scroll trap, the text-to-speech trap, the headset trap, and the layer trap. So the exit trap, you need to ensure there is always an accessible actionable item, e.g. a close button that meets color contrast requirements and has an accessible name, that closes any feature that overlays the current page, such as a full page ad. It applies to all users, and it's both methodologies. This is an example here. You have a full page ad. You can see there's text just at the bottom here, and there's no real way to close that ad. You can't tap on the address. The back button doesn't work. So that's basically the only way you can get around that, is to close the app and start again. This is a much more common example where you have a pop-up when you first go onto a page. And this fails because the close button is very, very small. It doesn't meet touch target size requirements. And it also doesn't meet color contrast requirements. So the swipe scroll trap is: ensure you do not override standard mobile touch functions, swiping, scrolling, etc., on the majority of the page. So this applies to touch users, and the mobile methodology is mobile site and native app. This is an example. It doesn't exist anymore. I call it the Zoom of Doom. If you swipe anywhere on the map moves. The only way to swipe up and down the page, because this is just a map on a page with content above it and below it, is to hit these small areas of white around the map itself. And that's almost impossible for a number of users. So that's the swipe scroll trap. The text-to-speech trap is: if the app has an ability to provide content via text-to-speech, the screen reader user must be able to pause or stop the app speaking in a similar manner, e.g. by performing a swipe on a screen. So this applies to screen reader users, and the methodology is native app. And this is an example here. This is Pocket. It allows you to speak an article, but once activated, you can't turn that speech off. Now, why would that be a problem? The problem is that a screen reader also reads aloud content. So in order for the user to find out how to turn off that speech, they're going to have to listen to their screen reader, but they can't listen to their screen reader because the article is speaking at the same time over it. And now this is extremely problematic, especially if then the next article just plays automatically. And then you've got a headset trap. So headset users must always be able to pause media, audio or video content by using the pause play control on the headset. This applies to screen reader users, headset users, and it's both methodologies. So here you have, this is just a weird thing, a website, and there's a video that's just popped up in the bottom right hand corner. If you want, and it has audio as well as movement, and if you want to turn off the audio, you just have to tap that little mute button. But of course, once again, the screen reader user, if they're using a headset and they hit pause, the pause doesn't pause that video, the pause pauses the screen reader, and they have the same problem as before. And last but not least is the layer trap. The user should not be trapped on a non-visible layer. It applies to all users, but mostly encountered by screen reader users, sometimes keyboard users, and it's both methodologies. So this is an example here. You have just an ordinary website, and if you tap on the menu, for the visual users, that's fine, but for the screen reader or the keyboard users, they are stuck on the underlying layer. So why is that a problem? Because A, they can't access the menu, B, they can't close the menu, and C, they can't see what it is or activate what it, as a keyboard user, they can't see what it is that the keyboard is actually on. So this is a real problem. So you can find details of each of these traps on the Accessibility Oz blog. I've put a lot of detail into them, so they are at least HTML, those ones. And then the next step is to test mobile specific issues. There's different categories in step 4. It's alternatives, display, actionable items, navigational aids, audio and video, forms, and mobile desktop interaction. So for mobile sites only. So I'll show you an example from the document. So everything that you see is in PowerPoint, but is actually in the Word document. So the requirement is touch gestures. Any touch gesture must have an alternative any touch gesture must have an alternative, accessible, actionable item. For more information, see Success Criterion 2.5.1 pointer gestures. So this is very similar to WCAG 2.1 requirement, the Success Criterion 2.5.1, but we have detailed it in this methodology as well. So what is a touch gesture? Touch gesture, swiping up and down or left and right, dragging up and down or left and right, double tapping, tap and hold, tap and swipe, 2-pinch zoom, and press and long hold. And so the requirement is any touch gesture must have an alternative, accessible, actionable item. So what is an alternative, accessible, actionable item? It is a link, a button, a drop down, or a separate page with the same functionality, coded in, coded accessibly, of course. So each requirement has an about this requirement section, which I'll read. You may notice that I'm reading from the slides, and that's because there will be some people here who can't see the content on the slides. So I'm making sure my presentation is accessible. So this requirement says, this requirement is particularly important for screen reader users. For example, if you require your user to swipe right to complete a purchase, when the screen reader is on, the swipe right gesture moves you to the next focusable item and doesn't complete the purchase. You must be able to perform the same action by using a link, an up or down swipe, or some other gesture. Please note that this requirement is similar to the exit trap requirement. A failure of the exit trap requirement is that a user cannot escape from a content or a page. A failure of the touch gestures requirement is that a user cannot choose content or a page, so they're not trapped. And then there's a how to test section, identify any site controls. If they require any of the following gestures, is there an accessible actionable item provided as an alternative? And then you have the different touch gestures that you need to test. So this is a past example. This is, a weather app. and you can see that some of the content is cut off on the right-hand side. That's a very common indicator that you can swipe from right to left to get more content. But as I said before, there are certain users that can't do that. So even though that content is there, there's also a link at the bottom that says see more, and that takes you to a page that has all the content in a linear fashion. So even though it does require you to swipe right, you can still access all the content by selecting that link. This is another example. This is Google Weather. Obviously, when I was putting this presentation together, I was very interested in weather. And you have a dragger, a dragging thing that you can drag to a particular time to determine what it is, what the weather would be at that time. But each hour and half hour is also a link. So you can just tap on those links as well. So that's another past example. So the next step is testing mobile assistive technology and features. And so there's one requirement that has to work across all the assistive technologies and features. And the requirement is all actionable items and content can be accessed and activated by the following assistive technologies or when the following feature is enabled. And so these are the Android assistive technologies and features that I mentioned before. You've got the iPhone ones and the iPad ones. So this is an example of the New York Times games, which I am very obsessed with. And here, what I've done is I've turned on voice control. And so the little highlight content, see where it says daily, 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 that's what's going to get read to a screen reader. That is basically the accessible name for that content. So you can see that they can't see the screen. You can see that the crossword, PAX, and archive, they're all called the same name. So a screen reader user is going to hear daily, daily, daily. And this is a common issue in New York Times games. So if anyone's here from New York Times games, please fix it. So this is names not being descriptive. This is another example, which is even worse, also New York Times games, where the letters that you're supposed to use this for the spelling bee don't actually have any names at all. So they're all just called image. So a screen reader user will hear image, 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 image. Another thing to be careful of is keyboard order. So here you can see the numbers, and the number indicates the order that the keyboard focus will be in. So you can see the first one is the first clue, and then the second is your down arrow, and then the third and fourth, fifth are your items across the top, and then 6 is the second clue, and then 7 and 8 are your items at the top, and then 9 doesn't exist, and then you go 10, and oh no, 9's down there, and then 11 and 12 is there, 13 and 14 is there, 15 and 16. You're thinking, oh well, that's 17, so that should be 17. But then you get down here and 55 is 21. Your previous button is 34, your next button is 42 in terms of the order that these things get read or tabbed to. So you can imagine that a keyboard user would find this almost impossible to use because the keyboard focus would be running around all over the place. This is another example, which is not as bad, but this is a talkback Android. So if they activate the clue, you would expect that it would take you to that item on the crossword. But instead, activating the clue takes you to the next clue. And that's, once again, there's no indication for a screen reader user as to what is happening. So that's just going to be really confusing. This is why grayscale can be a problem. Now, there's not going to be people using, monochrome displays. And if they are, they're choosing to use it. It's not an accessibility issue. But there are people who are colorblind or have various different color issues. And so the best way to test for them is to test your system in grayscale or in various different color correction modes. So if you see this, the left-hand side, you can see the yellow item means that one is in focus, but if you're looking at it in grayscale, you can't tell which one of those things are in focus. Now that's really easy to fix, right? You can put a bigger border around what's in focus. So these are the kind of things to be aware of. And then this one, this is increased text size. So as I mentioned, increased text size is very common. And so on the left, you have the normal size, and on the right, you have it on increased text size. And that's not something that you could use in any kind of way. That's not friendly at all. So that's the kind of thing that you need to watch out for. Another thing you need to be aware of is that if you increase text size in your system settings and it doesn't change, that's also a problem. So that's something else to think about. Okay, so what's next? I personally contracted long COVID in 2023. So the whole mobile testing methodology committee is kind of on hold, but there are a number of things that we need to do. We need to update it to include WCAG 2.2. We need to include additional assistive technologies and mobile assistive features, voice control being one of them. You can use the mouse with an iPhone now. Those kind of things need to be included in the methodology. We need to review existing test cases. Some of the traps that I mentioned, they're starting to occur on mobile sites when they only ever occurred on native apps, etc. We need to remove some assistive technologies and mobile assistive features because, for example, if you test grayscale on iOS, if it fails, it will also fail on Android. So you don't need to test both. You only need to test one. And the same occurs with color correction. The same occurs with reduced motion. So you don't need to test both devices. You can test one. And then the creation of an online resource is what I'm really, really, really hoping for. So thank you very much for coming. If you are interested, tomorrow, though it's going to be a terrible time for you guys, I'm actually running a session on WCAG 2.1 and WCAG 2.2 editions. And so if you know about WCAG and you need to learn about WCAG 2.1 and 2.2, please have a look at that. We're also running a bunch of training. As I said, it's going to be terrible, terrible time for you guys. If you go to training and then public seminars, that's where it is. We're doing training on WCAG 2.2 for content authors, for developers. If you're really interested in the mobile site and native app, I have a one-day training course which goes through every single criteria, accessible document principles in Word, PowerPoint, and Excel. And if you are interested in that, if you use the access code Game Dev Day is yay, doesn't matter about the case, then you'll get a 10% discount. This presentation will be available on the Accessibility Oz conferences page. And last but not least, you can access the methodology under the resources menu in the Accessibility Oz page. Does anyone have any questions?
Hi, Gian. Thank you very much for that. There's absolutely packed full of information and full of useful advice in there, I think. And I only counted one dog treat.
Really? Wow, they had thousands.
Yeah, you might have just been yeah, you might have just been sneaking those under the table while I wasn't noticing, but I thought I really caught one of them. But there we go. Lost my face there. Yeah, so I thought the examples you had with the New York Times were really fascinating. You know, it's especially the keyboard order on that, the crossword one there. That's really well. I mean, they're all pretty enlightening. I think really, you know, the keyboard order is pretty impressively painful, but also just the fact that you know, the letters are just all of them just read image, and everything's was marked as daily and stuff like that. So those are really tricky. But it made me think: are these games more suited to being having sort of accessibility baked into them, as it were, based on them being sort of like a puzzle game, and based on like an easy sort of structure there. So kind of, is there a type of game which is better suited to accessibility?
So I have to say the answer is no. I've always been so surprised at the number of different games that people use. And we actually were an accessibility partner for McDonald's for about 5 or 6 years. And they released the Sonic the Hedgehog game and a whole bunch of different games with their Happy Meals. And we tested them, and they were like, well, Sonic the Hedgehog, you're supposed to go around and collect things and it sounds and blah, blah. And we have someone on our team who is vision impaired and entirely reliant on a screen reader, and he made those games accessible by using sounds as well as visual identification and things like that. And he talks about how he plays games all the time because, if you think about it, someone who's blind, there's not a lot of audio described content. If you think about what we spend our relaxing hours doing, for me, it's watching TV or reading a book or something like that. Of course, people who are blind can read a book, but not a lot of content on TV or those streaming apps are actually audio described, so there's not a lot available to them. So what else are they going to do? And so games is one thing where it also often doesn't require a visual medium. So if you think about the spelling bee, it doesn't matter whether I can see or not to come up with the 100 words that have those 6 letters. So I think that it's really important, even more so, to make games accessible, because people with disabilities are kind of locked out of a lot of other content.
No, I absolutely agree, and I think it's it's a really important thing to be thinking of, and it's very easy to overlook it and to skip it and to miss it. But Sonic the Hedgehog, that's a fairly sort of surprising one to me. Again, because based on what you're saying there, it does feel like it would be easier, I guess, to implement it on these sort of puzzle games. So how would you go about doing something like Sonic the Hedgehog, which I think would require faster feedback perhaps than I would expect for an audio description type thing. So how would that kind of thing
So
work?
I personally I've never played Sonic the Hedgehog. I was involved with the game, but it was a long time ago. But if you think about it from Space Invaders, and that's a very visual thing as well, right? Space Invaders trying to eat things. So basically, you would have different sounds. Say if there was a diamond in front of you, then, it would make a particular sound. If you turned away from it, then the sound would become lower. If it wasn't on your particular area, then it would be on one side instead of the other. So it's really turning that visual content into oral content or audio content, which is something that we don't really think of, but isn't that hard to do. And I can tell you right now, these games, they were developed and then we added accessibility. It was not something that we had to build in right from the beginning. I'm sure it would have been easier, but it was added in at the end. Yeah. So it was, and there's some interesting documentation around, creating games for blind people and the kind of oral information, because people who are blind, they are much more sensitive to, oral feedback. So, being on one side, they'll notice much more, they can play in that way, in a way that perhaps we regular people can't.
Yeah, I can imagine.
I can imagine a separate set of Steam achievements for playing the game with the blind mode enabled.
But sometimes blind people are much faster at doing things, because when they use a screen reader, and I sometimes speak fast, but their rate, the screen reader voice, is often so fast that you and I could not understand it. It's just like gobbledygook, and they can understand it because that's how they use it all the time, I guess. So they can actually access a lot more information in that way than we would think that they could.
I've recently heard an like statistic that people were like human body was designed to operate with the sound more efficiently than with the vision. So, for example, in a fast-paced game like FPS shooters, the sound cue is often more efficient for you than what's actually happening on the game. Like you like on multitude times faster to react on a sound of like a step to turn and shoot than to actually see somebody perform something on the screen.
So audio is very different to visual content. One thing about audio is that it's not persistent. So visual content remains the same. Obviously, whatever changes, but I'm looking at a screen here and this side of the screen is not changing at all. So if I have difficulty reading, I can look at that part of the screen for 5 minutes to determine what it is that it says. But because oral content is not persistent, you can actually provide a lot more information, because you can have the sound increasing, you can have the sound changing in a certain way, you can have the sound loud, then not loud. So you actually can provide a lot more information because there's a lot more availability, and that's I think it's a really interesting concept to sort of think of games in that way.
Yeah. Do you think accessibility would almost force a change in the game mechanic? So if you're kind of having to do things differently based on what cues you're getting, would you have to change the game mechanic, do you think?
What I don't think so. I'm a really big believer in, there's always a way to make something accessible, and
Mhm.
also to make the existing system accessible, not create an alternative. And I think that it sometimes requires some thought, but I don't think that there's anything that you could. And correct me if I'm wrong. There's any kind of game that is so inherently visual, if you use that as an example, that you couldn't make it accessible to a screen reader. Because I mean, the most visual thing that I can think of is like Space Invaders, and I can figure out a way to make that accessible to a screen reader user. So I play a game called Two Dots, and it's a kind of array of dots, and you have to select this section to get rid of the fire and blah blah blah, but it's not timed. So someone with a screen reader could actually go through and select each dot, and it would tell you what it was that those dots were. Now if that was timed, then that might be a little bit different, but it's not timed, so a screen reader user can take the time to listen to those things, as opposed to just looking at it the way that we glance at it.
And I think the idea of something being timed could be, I guess, an allowance. Let me rephrase that as a question. Do you think it would be useful to have to add in allowances then for
Yeah.
which do change the game mechanic, because it goes from like a timed based thing that you got to solve to something which is more, I guess, endless type.
We did have that. Yeah, we did have that issue with one of the games with McDonald's, and they were like, no, this game, you've got 30 seconds, and you've got 30 seconds to choose all of these things, and that's it. If you can't do it in 30 seconds, and I'm like, it's a game. It doesn't matter if it takes someone 30 seconds or a minute. And so what they did is we had screen reader instructions, and in that screen reader instructions, we had play the game with an extended timeline. So it wasn't obvious or easy for people to choose. It was something that screen reader users would come across. And yeah, so they extended the time that way. But yeah, I remember it being no, people are going to get 30 seconds and that's it. And it's like, but these are, the whole point of games is to enjoy them and to have fun. And, it's not, WCAG talks a lot about this, about things being essential. And a time limit, for example, you need to be able to extend it, etc., unless the time limit is essential. What's an essential time limit? If someone's going up for an auction, if someone's doing a test, for example. But a game shouldn't have an essential time limit unless it's supposed to replicate something in real life. So I think that kind of extension, you can do it in a way where it's not obvious, but people who need it can get to it.
I like the idea of giving these allowances while using the technology which requires the allowances. So if you need a time allowance, a time extension, then it's available because through the screen reader itself.
Yeah.
So that's
Yeah.
a nice way of doing it, I think. Yeah. We've had a couple of questions in the chat. One was asking about screen readers and like a frame rendering engine. So not like a web-based thing like the New York Times, but more of an actual game engine. Can screen readers operate in that kind of an environment?
I don't know. If you can get that person's details, I can do some research and I can send you an email. So I don't know much about game rendering engines. Screen readers are pretty good at figuring things out. 20 years ago, they were terrible, but now they're pretty good. So I would say they probably could, but let me do some research.
Okay, thank you.
So there was another question, like, are you aware of blind shell? And if yes, do you have an opinion on it?
I feel terrible. I don't know blind shell. You have to give me a question I can answer. But once again, if that person wants an answer, I will have a look at it and send an email.
Okay, well, another question then perhaps. Someone's asking in the chat if they could share data on the size of the mobile market for people with disabilities. So I guess, do we know how many people are using the accessibility features?
Yeah, now that's an interesting question because every accessibility testing person in the world would like to know how many people are actually using the assistive technologies. No, you cannot get that information, for love nor money. In reality, it is important to realize that people with disabilities are more likely to use mobile phones than they are to use desktops. So if you have, say, 45% of normal people using mobile and 55% using desktop, you'll actually find that those it's kind of reversed. 55% of people with disabilities are using mobile and 45% are using desktop. The reason why is because people with disabilities are often come from lower socioeconomic backgrounds, so they have less money. So they often, will buy a phone because everyone needs a phone, but they won't have a laptop. They're often underemployed as well. So, I have a laptop for work. I'm not quite sure if I'd have a laptop if I didn't work. So they, once again, are much more likely to use their phone. Also, because of all the assistive technologies and features that are inbuilt into the phones, there are some people who know how to access content through a mobile phone and don't know how to do that on a desktop. There might be some ways by downloading certain products, but it's not obvious to them. They haven't learned how. They only can do it through a phone. So, mobile phones are much more used by people with disabilities. But in terms of who's using what assistive technology, unfortunately, there's no way to tell. Take it up with Apple.
Yeah, I mean, there's a bunch of fascinating points in there. I wouldn't have thought of those reasons for more people using phones. I wouldn't have thought of that as a statistic, but those reasons are all very, very interesting.
So there is a government kind of system in Australia called Job Access, which if you hire someone with a disability who needs an assistive technology, the government will actually buy that assistive technology. So when I hired a vision impaired person in Australia, she said, "Oh, I don't have JAWS, which is a preferred screen reader, but I'll get the government to pay for it." And then she said, "You know what? I don't need a laptop. I can do everything off my phone." And if you think about it, if someone's blind, why wouldn't they do everything off their phone? Because why would they sit in front of a computer? They can't see anything. Why I choose to use a laptop instead of a phone is because of the 3 monitors. If I can't see those monitors, and I can actually access Word documents, etc., through a phone. Why wouldn't I do that? And so we had a big fight because the government wanted to give her an iPad, and she said, I want an iPhone because I want to be able to carry it around easily. And they're like, no, you need an iPad. And she's like, I can't see the screen. Like, why should I have an iPad when an iPhone would be so much better? And yeah, eventually we got her an iPhone, and yeah, she'd be like, oh, so I'm sitting outside in the sun doing blah, 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 you know, setting up feedback forms, etc. So yeah, it is something that is quite common for people with disabilities to rely on phones more than, you know, desktop computers.
Yeah, and somebody's just mentioned in the comments as well that it's interesting how advertisers can track a whole bunch of things about us, and yet we don't have this kind of information. I think it would be really helpful if we had access to this kind of these kinds of statistics, because then it makes it easier to argue the case for actually implementing this as well.
But the problem with that is there aren't going to be any blind users using screen readers using the New York Times, because it's not accessible to screen reader users. So the New York Times could say, well, we don't have any screen reader users, so we don't need to make it accessible. So it's kind of a chicken and egg thing. So, you know, I think that there has been very much a kind of an overarching decision by policymakers and browser manufacturers and stuff like that to not report on this information. But yeah, I definitely can see a client saying, oh, well, we don't have any screen reader users, you know, we checked. And it's like, yeah, because, you know, no one can log into your site. So
Yeah.
that's one of the problems with it.
But it'd be nice to be able to get the information sort of industry-wide, as you say,
Yeah.
take it up with Apple and Android, to be able to sort of see that, okay, you know, maybe this site doesn't work with screen readers or other assistive technology, but people are trying to use it with those technologies.
Yeah, industry-wide, that would be fantastic. And I mean, that's what the WebAIM screen reader survey has tried to do, but specifically about screen readers. And that's a great survey, and it has really good information about who's using which screen readers and browsers and how often they use it, etc., etc.
Yeah, I think just to finish off, there are a couple of comments in the chat as well about different games and so on, which do work really well with accessibility features. So that's nice. Commented there that Last of Us does a very good job apparently, and they said if that can be made accessible, then so can many others.
Yes, true. I mean, the only thing I can think of that I can imagine you could have a game like, you know, those dance games where you have to, you know, jump on different colored buttons. I can imagine someone who's in a wheelchair would not be able to do that. But even saying that, like, I don't know what you could have it in front of you and press it. Well, even someone who's quadriplegic could have like a head wand or something like that. I always believe there's a way, and it comes back to, so many people think that people with disabilities just don't do anything. I mean, when I was working with Melbourne 2006 Commonwealth Games, Ticketmaster was the ticketing company, and they showed up with 7 project managers to a meeting with me when I was like, hey, you need to make your system accessible. And they said, well, you know, we don't need to, because people with disabilities aren't going to come to the Commonwealth Games. And I'm like, what about the Paralympics? You know, like, and they were like, oh, and I was just like, you know, you need to think about these things. And so people with disabilities, they're just like, we're all the same, really. So yeah, definitely try to, and some of the things are really easy to do. That keyboard focus order, I don't know how they managed to do that, but someone messed up somewhere. And adding, you know, names to things is not hard, you know. So yeah,
it's remembering it. You know, if you don't need to use it, then it can be hard to remember to actually do it. So making sure it's on your checklist and raising awareness to get it done, I think is really important. Lots of really great info and hints and tips in there. Alex, I don't know, do you have any questions before we round up?
No, I just was fascinated with the video. Like, I am personally a colorblind person, so that's one of the things that the first thing that I done when I came to JetBrains, having a color scheme that was actually working for me, and still it's the one that I'm using all the day. And I have a bunch of friends who are dyslexic, and they didn't know, for example, that there are actually dyslexic fonts that are available for them. That when I opened and showed them, and like, show them how to integrate them into the application of their choice. I said, like, finally, I was like always struggling to work with the application, and thought like that is my life now, that I will be struggling for the rest of my life. But now I'm actually feeling freedom and to be able to work with it. That's really nice.
Yeah, funnily enough, I'm slightly colorblind as well. I get confused between different shades, and some of the games that you've mentioned, like the New York Times ones, similar type things. It's not the is it New York Times? I can't remember. One of those sort of casual games where you just kind of guess at things. They had colors. Oh, it's Wordle. That was the one. Wordle. I think it was the green and the orange or something. It confuses me
Yeah.
now, and I have to really kind of concentrate. I have to put it into dark mode, so it's I think it's blue and orange now. So but now it's blue and orange. I can see that they're different, but I don't know which one's which.
Which is exactly.
I don't know which one means which. Anyway, thank you very much for your time, and thank you very much for a really interesting presentation. I hope we'll all take a whole bunch of awareness away from this and try and improve the accessibility in our own games and products as well.
Excellent. Thank you very much.